Holy. So just to say a few words about chapter 10, in case you want to give it a try. Chapter 10 is where we finally get even more realistic. Can somebody tell me real quick, how would you test if you made a brand new drug? What would you set up to test how good it is? What would you set up? You should know this, even though we haven't really talked about it. You should know this. Just say
an experiment with a control group.
Okay, good. So you would have one group that does what?
That takes the drug.
It's the actual drug. And then you have, now in reality, you have two more groups. Let's pretend like we have one more group, and what happens with them?
They don't take the drug? It's a placebo?
Yeah, they take a placebo. Now, in reality, you would have a third group that doesn't do shit. They just keep going like they've always been going. Now, everybody's aware of this, right? This is nothing like, you haven't said anything about this, Jeff. Well, you guys know this. You should know this to some extent. So what chapter 10 does is, if I have a sample of people taking a drug and I have a different sample of people taking a placebo, isn't that two samples? Right? Of course it is. That's what I just said, two samples. The formula from chapter 9, the whole idea of chapter 9 is comparing one sample to some known mean, right? Like, it's always been 11. I think it's less than 11. Let's test that shit out. I mean, that's chapter 9 in a little play form, right? Chapter 10 says, what if I take two samples? So watch what happens. I'm not going to talk about this much because it's extra credit, but look what happens to the formula. I want, and real quick, I want this to make all the sense in the world. I'm not going to spend a lot of time on this, but isn't the formula, so this is basically the new Z star formula. Wasn't it this before? Right? Is everybody with me?
Yes.
There was one mean sample, and there was one population mean I'm comparing it to. And then there was one sample size, and there was one standard deviation, right? Okay, look what happens here. So instead of one, there's two. Of course there are, like I just said, there'll be two samples. Instead of one population, there must be two populations that I draw my two samples from, right? They could be get the drug, don't get the drug. They could be freshmen, seniors. They could be people with a college degree, people without a college degree.
Oh, I think he's back now. The host just changed.
Did y'all get far into the 10.2 or just a couple of minutes?
Just a few minutes.
Yeah,
I barely started.
9 and 10 make a lot more sense than 8. Something about 8 didn't click for me. I'm going back into the old lectures today before I take the quiz.
Can you guys hear me?
Oh, hey.
Yes.
You're
Okay.
blue.
I know, it seems appropriate. Unbelievable. The whole morning, beautiful internet, no problem. High streaming, all kinds of shit. And then of course the minute class starts, just, whatever. Oh, please. You're fine, obviously. So I'm glad, in fact, I think everybody stayed. That's awesome. So thank you for that. I was worried. Anyway, all right. So let's all find out how long this lasts. Hold on. All right. So you guys, if you want to keep talking to each other, go ahead. I'm chatting with a Cox person right now, which I always found an appropriate name for this company, but let me see. Now that I'm here, I probably killed the conversation. I'm sorry.
Something happened to a bunch of us all at the same time, I think so.
Oh, really?
The network at my high school, it just came back up. It took about 15 minutes.
Oh, I see. Interesting. So now I feel a little less alone than I did yesterday. I felt alone in the universe with my Cox problems. Which is not
I have Cox also, and my TV, we were using the internet through the TV, and it just buffered for quite a few minutes as well.
All right, hold on. Let me send this people a message, and then we'll get started back up, okay? Sounds like... All right. Okay, let's see, back to teaching. Hope you guys can give me some service for all the freaking money I throw at you. Maybe I shouldn't say it.
It's painfully true because I pay a lot for Cox as well, and I've had many problems with them.
And there's like no options. There's nothing else. Besides, well, you can do AT&T and Verizon, but I've heard horror stories from them too.
Right,
I-
exactly.
I have Spectrum, which is Cox, right? They
Right.
merged.
I think they're owned by them or something like that.
It's all one gigantic cock.
So weird thing is, when I moved here, I heard Cox was bad, so we ended up going with AT&T.
Yeah, and is that okay?
What was that?
I don't
I've
have
heard-
much problems with it.
I've heard people that say they have no problem with AT&T, and then I've heard people that say it's worse than anything in the universe. So I don't know.
But I think it depends where too, because
True.
I'm in Vista. I'm not in San Diego.
Oh,
My
Yeah.
experience with AT&T is it's great until you have a problem, and then everything is awful.
yeah. It's pretty similar with Cox too, because like they tried to double my bill when I first like turned on my Wi-Fi where I'm at now. And it wasn't until I actually went into the store and talked to the general manager that I finally got it solved.
16. I'm trying to see if I can find my. There I am. Okay. I exist. Okay. At least digitally. As far as you guys know, who knows? I could just be a Max Headroom artificial intelligence thing. Nobody gets that Max Headroom reference today. Maybe a couple of you. What's next week? What is next week? Next week? What? All right, let's turn everybody off. There we go. Let's highlight me because it's all about me.
I think I saw an article, I think yesterday, somewhere about something about a solar storm. I don't know if that has anything to do with this.
Interesting.
letter, But
I normally know when those are happening, but maybe you're right. I didn't really. Oh shit! Am I doing it again?
Your picture is frozen, but we can hear you.
All right. Hold on. Let me check what's going on. Shit. All right, you guys are still moving. Can everybody I see kind of like move a little bit? Oh, there you go. I see. Okay, thank you. All right, let me check my. Oh, I just. It's amazing. Teaching is already not the easiest thing in the world, and then when you add this on top of it, it's like, what? All right, it's telling me that it's fantastic again. All right. All right. All right. Let's find out. All right, everybody. Oh, I'm blue again. Dang it. I just can't get everything at one time. Hold on. What? Either I don't, maybe I just don't exist or things work. I don't know. And now it's telling me that I exist already. There I am. Oh, God. Okay. Shite? No? Okay, good. Sorry. Okay. There you go. All right. Okay. Did anything come up while I was gone that you need addressed? Anybody? Anything that needs discussion? Any questions that went unanswered? Anything?
No,
Okay.
I think you were just beginning to talk about 10.2.
Yeah.
last thing you said was, I think it was two samples, those who had a college degree and those who hadn't.
Yeah. Well, I was more talking about while I was gone. Did somebody ask a question that needed answering? But yeah, we can get back into this stuff. And I like it. Somebody in the chat is private messaging me technical things to do. And I'm like, yeah, I did all those. But I appreciate that anyway. Thank you. Anyway, so what I was trying to say was, I kind of hope this makes a little bit of sense. I mean, this formula has one sample in it and one standard deviation. This has two. Of course it does. Now what's down here, real quick. Sigma, this is this, correct? Is anybody, right? We know that formula pretty well. Does anyone understand that I could do this? Right, because what is the square root of sigma squared? Wouldn't it just be sigma? Aren't these the same? So how many of these do I have? How many square root of sigma squareds over n do I have? I have 2 of them. Of course I have 2 of them. I have 2 of everything. So do you guys understand what I mean when I say those 2 formulas are the same? This formula, this monster, is exactly the same formula as this. It's just everything's been doubled because now there's 2 of everything. Does that make any sense to anybody?
That makes sense, but I guess my question is, like, if you're looking at the people taking the medicine and the people taking the placebo, what is that z-score really giving you as a result? Like,
How far apart those 2 results are.
okay, that makes sense. Okay.
That is fundamentally what the formula would do. And let me tell you one more thing that'll help anybody that wants to try this section out for extra credit. The null hypothesis, doesn't it always have an equal sign of some kind in it? Right? Right? Isn't that what we're assuming is true? So guess what happens to this piece? What's true about mu1 minus mu2 if they're equal to each other? Doesn't this just go away? It becomes 0, yes? Okay, so I know, and that's all I'm gonna say. It's extra credit, you can try it out if you want to. The formula looks gross because it's bigger, but it's really the same formula. Okay, all right, we especially have less time now, so I'm just not even gonna say more about it. It's totally up to you if you want to try to do it. Okay, so what we're getting into now, why am I doing what I'm doing? We just finished chapter 9 and I just spoke about chapter 10, correct? And what are we gonna do next?
Chapter 12.
Yeah, and then what are we doing after chapter 12?
Chapter 11.
What? Yes, we declare bankruptcy after chapter 12. Why am I doing that? Because guess what chapter 11 gives us? Can anyone guess? Remember how I had to redo chapter 8?
A new distribution.
Holy shit, yes. So chapter 11 is going to be, guess what, guys? Chapter 11 is going to be a different chart. It's going to somehow be related to Dragon Ball, believe it or not. If anyone knows that. And now you all know that I'm into One Punch Man and Dragon Ball, all that kind of shit. Okay, maybe. Noise. Okay, now. So that's why I do that. Chapter 12 is actually should be kind of a nice break from kind of weird shit and new charts and stuff, believe it or not. All right, so let's see how we feel about this. Has anybody ever heard of the idea of 2 things are correlated? Why am my camera's like right up in my grill? Get back. Okay. Anybody? Correlation? Anybody ever heard of correlated things?
They
Yes.
have like a similar pattern, but not necessarily caused or like related. They just
Good.
have to look similar.
Yes. So isn't there a correlation between the time you went to bed the night before a really early morning test grade? Right? Don't you think there would be a correlation there? Right?
Yep.
Okay. Or one of my favorite examples, this might be why I have this job, because to apply for this job, I had to video record one of my lectures and send it in. And that shows you how old I am when I just said video record. But, you know, I had to put it on a tape. There was these tapes. And the lecture I did was this one where I talk about the number of drinks you have the night before an early morning test and the grade you make. Would there be a correlation there? Probably. So let's take a look at this. I know you're not going to believe this, but I have a handout. I'm sort of like the Elizabeth Warren of handouts. She's got a plan. I've got a handout. Let me open it up. Where are you at? Unit 12. There it is. So this is called the basics of correlation and what's called regression. Right. So I'm not going to hypnotize you and try to take you back to a past life. That's not the kind of regression I'm talking about. So we're going to figure out what the hell that means in a minute. But can you guys pull up that sheet? It looks like this here with, it looks like it's got measles, right? All over the place. Okay. And I'm going to do like normal. I'm going to open this up a different way. so I can interact with it better. If I can find it really quickly, you can do it, Jeff. That's not it. Can you do it, Jeff? You can do it. Come on. Where are you? Where are you? Correlation. There you are. Yay. Let me pull it over there. Okay. So let's take a look. So this idea should be relatively straightforward, I'm hoping, compared to some of the other stuff we've done. And this is one time I'm actually gonna let you use the calculator a decent amount, believe it or not. Right, so for those of you that are like, he won't let me do inverse normal, well then, calm down. I'm gonna let you do this whole chapter on the calculator. It's gonna be, you have to interpret what the calculator spits out. So let's talk about the idea. So look at this situation. So an entire class goes out the night before a test that is happening at 7 a.m. the next day, right? Oh shit, what is it doing now? Hold on. Okay. You keep a record of how many drinks everybody had, and then you see how they do on their test the next day, right? So these two represent the same kind of thing, maybe two different classes. Can somebody tell me, do you guys get the general idea here? So both of them show that as the number of beers go up, what happens to the grade? Whereas the grades go down, what happens to the number of beers? Anybody? Is there a trend in both?
The amount of beers increases and the grades go down.
Yes, I like it. Right? In fact, I mean, this one's really easy. If I was to draw kind of like get this is neat. This is not the best I could do here. This is not very good, but do you see what I'm trying to draw? I'm trying to draw like the middle line. Believe it or not, this line is called the line of best fit. That is not my name for it. It is the name. Now listen up, kids. What that line tries to do is it tries to average out all the points locations. So it wants to be, another name for this, it's called the least squares line, which I don't know if that's really helpful. Jeff, why are you saying that right now? I don't know. So it's trying to minimize the distance from every point to the line. Are you guys semi with me? Like if I drew a line here, that obviously sucks because all the data points are far away from that line. Why am I using this? Oh shit, did I do everything with this? I did. I'm sorry guys, hold on. So this line I could draw here is sort of like, I think of this as a visual average. Does that not make any sense to anyone? Does that make sense? It's a visual average of all the data points. And again, that's called the line of best fit. So this one was easy. Why was this one easier to draw than it would be for this picture? Why is this one easier to draw?
Because all the points are pretty clustered. Not clustered, but like together.
Yeah, the points already kind of line up, right? So wouldn't you say that the points are pretty tight, pretty close to this line? Yes. So what about this one? What can somebody pick out? Let me just say this. We don't have the most time in the world. So let me ask you this. What's up with this person? Oh, I gotta check. It is being recorded, right? Yes, it is. Okay. What's up with this person here? What's their deal? Did they drink a lot compared to everybody else?
No.
I know I don't give you a scale, but I'm hoping that the scale isn't this guy drove 10 beers, because then these people are probably not still with us, right? So the scale is like maybe 1, 2, 3, 4. What's more important is they relatively drank few beers, but did they do well on the test? No. All right, what about this person? Did they drink a lot?
Yes.
Yeah, it looks like they drank the most, right? Didn't they drink the most? They're almost tied with this one, but I think they drank the most. But how'd they do on the test?
Better.
Relatively really well. They almost tied for the highest grade. Do you guys see that? Okay. So those two not surprisingly, would be outliers. So it's a little easier if I think these are outliers, then the line kind of is here somewhere. Do you guys see that? Does that make sense? Maybe? Okay. Obviously, which relationship, 1 or 2, is stronger?
2.
2.
2 is obviously stronger. There is a relationship here. There is a trend down, but it is weak. Weak, right? Why is it weak? Because the data points don't really always follow the trend well. They buck the trend more often. Here, almost every freaking data point follows the trend. Right? Now, which one's more realistic?
The one on the left?
Yes, because is the number of beers you drink the only variable that affects your grade?
No.
So this person didn't drink anything, basically, but they did shitty, right? So even if they would have drank anything, do you think they would have done better? No, probably not. This is the person that would have done bad no matter what. And this person, 2 things. They probably studied or they took the class already or something, and they can handle their beer, right? Their hangovers aren't terrible. And we're all like, whatever, it's good for you. Okay. You guys okay out there? All right. Okay. Yes.
What I know that, or this is just like really vague, but what do you call the line that hits the most points? It's not the line of best fit. There's another one, and I'm getting it confused.
The line that hits the most points.
Isn't there like a line that touches the most data points, or am I just making that up?
I'm not going to say that you're making it up because I don't profess to know every single thing there is to know about statistics. So there might be a name for that, but it doesn't make sense to me that there would be a name for that. Because what's important, that might be an entirely different process. Because what's important in this process is to capture the general trend. So I could draw the best line of best fit ever, and it might not hit any data points. Does that make sense?
Yep.
Okay. Just because they all have a little wobble to them, and then the line goes right down the middle and doesn't hit any of them. So I think that might be related to a different process with a different goal. Okay.
What was the other line that you were talking about earlier?
The other line.
It had squares in it. I forgot.
Oh, it's just another name for this. Sorry.
Oh, okay.
It's also called the least square. So real quick, since I said this name, least squares line. I really want you to understand this is very much like what I call, I call this related to a 2-dimensional standard deviation. Which one of these has a larger standard deviation, do you think?
The one on the left?
Yes, because the line is like the average. And of course, standard deviation is all about how far away you get. So the least squares line is the line that would have the smallest sum of squared differences between the points and the line. And everything I just said about least squares line is not very important. I just want you to know why that name is there. Oh, somebody that helped. Okay, that's good. Normally that's confusing. Okay. Just remember when we calculate standard deviations, what's one of the first things we do? Don't we square the differences? Because somewhere on one side and somewhere on the other side. That's exactly what kind of happens with the humongous and really beautiful, but I think you might call it gross math behind this, is we square the distances between the points and the line. Okay. So there's 2 things we're going to do. There's 2 things I want to know. One of them is what's the equation of the line? And the second thing is, how do we have a way to measure the strength of the relationship? And we do. All right, so there's going to be 2 things we want to calculate. So just before we do, real quick, can you guys tell me, especially compared to these 2, which one is a negative relationship and which one's a positive relationship?
The first one is negative.
Is a what?
Negative.
Negative relationship, that's right. And that's not a judgment call about drinking beer. It's why is it a negative relationship?
Because it goes from high to low.
It goes down. It's got a negative slope, right? Oh yeah, we're gonna talk about slope and y-intercept and all that kind of shit. Oh, Jeff. So what about this relationship? Obviously, the more you study, you should expect grades to also go up. By the way, real quick, is it the number of beers you have that affects the grade you make, or is it your grade that affects the number of beers you have? Has anybody ever went drinking because your grades were shitty? Okay.
Depends on which comes first.
That's true. So in general, somebody said something really good. Now this one's a little bit more clear. This one we kind of know for this specific case, it's the beers that seems to be affecting the grade. But maybe, I'm not saying this is true, but maybe, I don't even want to say it because I know it's not true. But some might say that good students drink less or something. This is not a true statement. But that's another possible explanation. If you're a good student already, you're going to drink less. So of course you're going to make a higher grade, and it's going to look like the beers affected your grade. Does what I just said make sense? Pretend like this is a true statement. If you're a good student, you drink less. So if I look at the number of beers somebody drank and look at their grades, weren't the lower beer drinkers going to have a higher grade anyway because they're the better students, you know, just in this imaginary world? You guys understand what I'm saying? So are there, and obviously there are other variables that affect grades, right? But it looks like there is a, in this case especially, how many circles you're going to draw, Jeff? I don't know. In this case especially, it looks like the number of beers and the grade are very heavily correlated. Meaning is one goes down, the other one goes up because it's a negative relationship. Okay, let's do one more example relationship. Our study grades. So which one is stronger just by looking at it?
The one on the left.
Good. The left one is stronger. Which one's more realistic?
The one on the right.
Yes, because who's this person?
An outlier.
They're an outlier, and there's another one. But what's specifically this person's deal? Did they study a lot? Relatively?
Yes.
Yes. How'd they do?
Horrible.
Not good. What about this person? Did they study much?
No.
No, but they did relatively well, right? And you know these people, and then they open their book, and it's the 5th week of class, like it is right now, and they open the book, and the book goes like they never opened the damn thing, you know. And you're like, what? You're getting 90s, and of course, it could be because they took the class before. So just get off your own back. So again, I could try to draw a line of best fit that kind of pretend like this is straight. So this is a line of best fit. This is trying to average out where all the data points are. And this one actually, do you see how this one actually looks like it might be curvy a little bit? I want everybody to realize that we're only going to talk about straight lines. We could talk about parabolic correlations, but let's not do that, right? I kind of want to, but we won't. So we're just going to stick with a straight line correlation. Okay. Now, so there's a neat symbol. Well, I mean, it's not a neat symbol, sorry. It's a neat idea. There's this idea of what's called a correlation coefficient, and that is related to the strength. So let me ask you this. If I had a situation, what kind of correlation would you say there is here? With that picture? None. Good. Doesn't it make sense then that the thing that determines how strong the relationship is should be 0? So this situation would have an R equal to or close to 0. Is everybody with me so far? That's kind of nice. Like, okay, thank God. That makes sense. No correlation. The thing that measures how strong it is should be 0, right? So what about if it's perfect positive correlation? Look at these data points. Do you see they're perfectly lined up because I made them that way? That is perfect. You can't be any better correlated than that. They are perfectly lined up. And this would have an R of 1. You guys with me so far? Now, I'm going to show you in a minute the formula for R, and we're not going to use it. And I'm not just showing it to you to freak you out, because it is kind of gross. But I'll show it to you in a minute. Now, what do you think? What would your gut tell you? What if it was a relationship like this? What do you think R should be for that relationship?
Negative.
Negative.
Perfection. I love it. So -1 means perfect down slope. What does perfect mean? All the data points are on the line. None of them are off the line. Right? R equal +1 is perfect positive, and R equals 0 is no linear correlation. Right, let me stop for a minute. You guys, I'm hoping this already feels a little bit better than, for example, hypothesis tests. Right? And of course, you don't even know what your work looks like yet. So you guys are like, I'm reserving judgment until we do a problem. I understand. And then we have the line of best fit. And we're going to have the calculator calculate the equation for the line of best fit for us. That's kind of nice. Okay, so the other side of this. Oh, let me do this. Let me do this. Before I do this, let me show you the R formula. You should have looked it up earlier, Jeff. Oh, well, too bad. This is not the right place, is it? Come on, Jeff, you can do it. You can do it. There it is. All right. Oh, dude, are you ready? You're not ready. You can't be ready, so I'm just going to show it to you. There it is. Look at that. Just bask in the glory of that equation. I mean, that's does anyone see anything that looks familiar in here? Anything?
Sigma number X
Why?
Y.
And why do you think there's X's and Y's? Why do you think that's true?
It's X points and Y point.
Well, X parts and Y parts, right? Every point has 2 parts. So it's going to be like beers could be X's and grades are Y's, right? What I didn't do earlier this semester, just because I haven't done it in a while, but there is an alternate definition. There's an alternate equation for standard deviation. This is actually part of the equation for the standard deviation of X's, and this is part of the equation for the standard deviation of Y's. It makes sense that standard deviations show up in the equation for R because R is sort of like a 2-dimensional standard deviation. All right. And on the top, look at this. This is kind of like the relationship between the X's and the Y's, which makes sense. That should be the main thing. That's what this is all about. Are those two related to each other? Right? That's what we're trying to figure out. Okay, so let's not look at that anymore. Because we don't have to. Go away, you're scaring my students. Okay. So coming back to this, where'd you go? There you are. Look at the other side of this. And this is where I wish I had figured out what's wrong with my calculator program on my computer, but too bad for me. I've got the excerpt from the TI calculator guide up here. So this tells you all the things you have to do. So let's do this before you try to read all the way through them. Can you please take a minute and put into L1 that data for beers and L2 that data for grades? Can we all just do that together? Okay. I actually haven't tried that calculator. Let's see if it, you never know, it could fix itself, right? Ooh, holy shit. Sorry. Holy shit. Okay, that is so neat. How often does that shit happen? Never. It did fix itself. I was completely joking. I'm really sorry, guys. Some of you guys have no idea what I'm probably. My emulator on my computer is working now out of nowhere. Okay, that's awesome.
Can you scroll down just a tad bit?
Yeah, I'm sorry. Hold on. Where am I at? I'm gonna find it. Here it is. this data here, right? Just do this data right here. You guys with me?
Yes.
All right, so let me do the same thing. Let me put this in my calculator that is working now. Kick ass. Okay, let's do this, Jeff. All right. That's so awesome. I can't get over that. I guess it's the universe trying to make up for my internet being shitty. You're like, let's throw him a bone. Let's make his little calculator work. All right. So one quick thing you want to be, now, what I do for myself when I'm putting a bunch of data like this in, when I get to about right here, I kind of make sure that I'm in the right place here. Does that make sense? Like 90 has got to be next to 2.3. Does that make sense? Just what really sucks is when you get to the bottom of the second list and they're not the same size. That sucks. Yes. Would you ever want to sort these two lists? What do you guys think?
No.
Hell no, because the X and Y go together to define a person. If I sort these lists independent of each other, I've torn my people apart, which is never, let's not do that. I like that somebody's making a joke about correlation between my internet working and my calculator working. That might be true. That was good. I appreciate a good stats joke. All right. I'm gonna switch over to my calculator. You guys ready? Okay. Let me see. Let me show you this. This is so awesome. Look, he's back. He's back. I'm not even mad that you were gone for a little while. All right. So everybody's got the data in their lists. So here's what we're gonna do. What do you guys think? I haven't said this yet. I should say this right now. The reason this is called correlation and regression, that regression word is it's saying that the data points would regress to the mean. That as I draw the line, I'm trying to draw where things should be. So it's this regression means motion, moving back to the middle. It's a little more than that, but it's enough for now. So what do you think? Now watch this. If you got all the data in here, hit stat, and I want to calculate. I want my calculator to tell me what the hell the line of best fit is and what the hell the R is, right? Oh, before I do that, sorry, let me derail this a little bit. Let's first get a scatter plot. You guys remember what a scatter plot is? It's just the data points, right? Sort of like the scatter plots on the other side of the sheet. So if I go up, look above y equals. Do you see where it says stat plot? Right there above y equals. So if you hit second, y equals, you get plots here. Let's all do this just to make sure we're on the same page. Can everybody just hit the number 4, enter? So it should say plots off, done. Okay, so go back to second, y equals. Everything's off. So let's do number 1. I don't think we've been in here yet, but look how evil I am. Do you see what it could make for you? What's this? There you go.
A histogram.
What's this?
The box plot.
Okay, sorry. That's why it's good to get the manual, kids. Now, so let's everybody turn this on. Enter. So now it's on. Everybody select the scatter plot, right? Don't have these other things selected. And then Do you see the X's are in list 1, the Y's are in list 2, right? Right? Everybody with me? And then you get to pick. This is going to be how they denote every data point. Do you want it to be a square, a plus sign, a big piece of dust, or a small speck of dust? So however you feel. I am always the square because I'm a math teacher. So of course I'm a square. And not everybody's going to have this magic ability to pick a color. I'm sorry. You guys might have an older calculator and you can't do it, but I can. So sorry. So I'm going to pick, I don't know. What color should I pick? I'm going to see to do this. Magenta. That seems fine. Now, is everybody with me? Everybody's got this set up the same way? Make sure it's on. Now watch what happens. If I hit the graph button, I'm sorry. Well, one thing is, do I see any data? No. So let me, and another thing is I see some crazy line. Did anyone get an error? Everybody okay? Did anybody get an
I got an
error?
error.
Does it say syntax error?
Yeah.
Okay. Does it say go to?
Yeah.
Select go to. Don't select Goku.
And then it has a y1 equals black square minus.
So hit clear. So you want to make sure everything's clear out of your y equals, or else it's trying to graph some weird shit, right? Now, hang on with me. So if you hit graph, your graph might look like this. Some people it might look like this. Yes. Okay, and you're like, okay, Jeff, what the shit? I just put all the data in this damn thing. We picked all the things, whatever. So here's what it is. Hit zoom. You have to tell the calculator to go find the data. It doesn't know what you want. It's dumb, remember? I'm sorry, man. I'm sorry, calculator. Don't turn off again. So hit zoom. And then can anyone see the option that I want to pick? Did I turn Y on? No.
Zoom stat.
Zoom stat. So what I did in Y equals, somebody said I just cleared it. I just hit the clear button. If I have anything in any of these, I cleared it. And now in zoom, I want to hit zoom stat. So for me, it's number 9. So if y'all do that, I get this field of magenta boxes. Let me know right now if you're having trouble. And anybody get something that looks like this?
Yes, it looks like this.
Yes. Yes. Okay. And if you look back at that paper we were working on, this should look roughly like the very first graph. See, this is an outlier and this is the outlier. So I try to pick data points that would make it look like that very first graph. Now, stay with me now. And by the way, just to make sure everybody really pays attention, on the final, part of your final is going to be to graph the data points and the line of best fit, take a picture and submit it with your final. So you have to be able to do this. Okay, let me see something, get in chat. Can you juice the steps? All right, I don't know. I can show the steps. All right, so what we did, we put the data in our lists. We went up to stat plot. You don't have to do this ever again if this is your calculator you've got. You can just keep this sucker on. Then you go to zoom stat. Anytime you put new data in, you've got to hit zoom stat so it finds the new data. Is that all right? I did them again. Is that all right? And again, this is what if you go look at the sheet, the handout, those are the steps I tell you in the handout. Okay. So what's missing is the line of best fit and how strong this is. Now, what did we say? Did we think this was a strong relationship? Definitely not. So our R value should be close to what?
0.
0.
But it won't equal 0 because there is still, I can still see a downtrend, right? Yeah, I like it, but it should be pretty weak, especially because the outliers and all this shit. So it should be small negative, like negative 0.2 or something, Right? Does that make sense so far? Should be close to 0, but it should still be negative because there is a bit of a trend. Okay, so let's just get the damn thing, Jeff. All right. So everybody go to stat, calc. And which one of these seems like, what's funny is there's 2 answers here. But which one seems like it would give me a line of best fit? And it's related to linear regression.
One for stats.
No. Let me say it again. So does anyone see the equation of a line? They just have a different slope.
Number 8.
Or 8.
4 or 8. And it's really hilarious to me that if you really don't want the letter A to be your slope, then you've got option 8. All right, that's a joke, everybody. I'm sorry. But I have no idea why they hardwired 8 when we have 4. So I always just use 4. So I'll use 4. So what this is going to do, it is going to use that formula we saw in the book to calculate R, and it's going to use some other formulas I didn't even show you to calculate the line of best fit. So if you hit 4, tell it what the X list is, tell it what the Y list is, and then go down to calculate. Now, if some of you guys have an older calculator and it just says lin reg, just hit enter because it defaults to list 1 and list 2. Let's see. Did everybody get that? I'm going to say no. I'm going to say some of you guys didn't get all that. Did some of you guys get some of that? How much of that?
Y, A, B.
Yeah, you got yab, right? But you're missing the R's. Okay, so did anybody else get the R's? Did any of you guys get the R's?
Yeah.
Okay. So don't feel left out if you didn't get the R's. Don't worry. Oh, okay. All right, let me check in real quick with somebody. So that was all we did with this, Billy. So did you get that?
Yeah, I got that.
You're good there. You're good there. So then we went to stat, and then we want to calculate something, and we want to make the calculator calculate the line AX plus B of best fit. So we want to use number 4. Make sure it knows what the X's are, where the Y's are. Or if you have an older calculator, it just says lin reg, in which case you just hit enter because it defaults to list 1 and list 2. All right, now, stay with me. Everybody still with me? I know you can't see your R, but look at the R that I got. Does it make sense? This R is negative 0.34, roughly, right? That's closer to 0. It's negative because there was a downtrend. You guys, I really want that just to make sense by itself. So what if this would have been an R like negative 0.87?
Mine just gave me the Y, the A, and the B.
Don't
no
worry.
R's.
We just went over that. I'm going to show you how to get the R, but I just want to talk about R while it's right here. What if R would have been negative 0.87? What would that mean?
It's closer to the perfect negative correlation.
Good. So it wouldn't be a weak correlation. It would be a
Strong.
strong correlation, possibly. So we'll talk more about where does it stop being weak and when does it become strong. Don't worry, it's not going to be as freaky as all that. Does that make more sense? So the closer it is to negative 1 or 1, the stronger it is. The closer it is to 0, the weaker it is. In fact, if it gets too close to 0, it could mean there's no correlation. It's not even that it's weak. It's just that it doesn't exist. So how do I get the R to show up? So I'm about to do something. If you have your own calculator right now, you will never have to do what I'm about to do ever again. It's really silly that they have this option. They should just automatically turn this on. So watch this. This is kind of cool. You ready? Hit second 0. This is the catalog of every damn thing this calculator can do. So for example, what's the very first thing? What do you think?
Absolute value.
Absolute values, right. This is not an abs workout. I'm sorry. This would be absolute value. So what I want us to do, we got to get to something called diagnostic. Now listen to me, listen. This is a one-time thing. I don't give a shit if you don't quite understand what you did. If we can do it, who cares? This is just going to turn R on, right? So I want to get down to the D section. So this, well, look, do you see this this button right here? It's got the little D on top of it.
Yes.
So click that button. And now you're in the D section. And then scroll down until you get to diagnostic on. And again, this is a one-time deal. So don't sit there going, how the shit am I going to remember to? Well, you don't have to. Once you get to diagnostic on, hit enter, enter. And like almost everything, this is very anticlimactic. Done. So, is everybody with me? Anybody still behind? What's up? Let me know. Whenever we have technology day, you gotta let me know. Is everybody with me? What are you doing? I don't know. Oh, I gotta check. What did you select? Oh, okay, let me go back. Catalog, diagnostic on, diagnostic on. This used to be important in like the TI-82 because if you turn this off, you could conserve some processing power. But nowadays, we have so much processing power, who gives a shit? Which is why everybody's code is shit, but we're not going to get into programming. So diagnostic on, enter, enter. That's it. Is everybody with me? Now, if you go back, you're like, okay, great. I got the letter, I got the word done. Yay. All right, so go to stat, calc, number 4, blah, 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 blah. Now everybody should have their R showing up. Okay. Let me let that just sit there for a minute. Okay, now. So does everybody agree that that R is pretty much what we expected? I sort of led you down to what to expect, but I didn't hear a lot of opposition. But is it jive with what we thought should happen? It's closer to 0, it's negative, all that kind of stuff. So can somebody tell me what the equation of the line of best fit is? What is the equation? What's the slope? Anybody tell me? What letter do they use for the slope here?
A.
A. It used to be what in algebra?
M.
M, and they think that the urban legend is that it's M for marcher, which is French for walk or march. And who knows? Why not? Sure. But they want to use the letter A because they're not mathematicians. This is statisticians, so we have to be different. So the slope is negative 2.54 roughly, right? And the y-intercept is
89.83.
89.83. So let's do two things. Let's go back to our sheet. Let's write this sheet down. Go to the sheet and write this sheet down. Somebody's going to have to help me remember. So this was negative 0.33. I can't remember. Right? Somebody help me out.
0.339.
339? Okay. And then is this strong? Hell no. What kind of correlation? Possibly weak negative.
So A equals slope, D equals y-intercept.
Yeah, this we remember from algebra, right? Mx plus b. So
Yeah.
here's ax plus b, because who cares about letters? They're just dummy placeholders. So they should use the letter A. All right, now somebody else remind me. I really can't remember at all. Wow, Jeff. What was it? Negative 2.54?
Yes.
Plus
89.83.
89.83. Is everybody with me? So we got the R, we got the line of best fit. What do you think? Look at this interesting word I put here. Trust. If I want you to understand what this could be used for. What did X represent again in this problem? What does X represent?
The number of
Years.
years,
Spheres. And what does Y represent?
grades.
Grade.
So what if you drank 2.5 beers? Could you estimate what your grade will be on the test using this equation?
Yes.
Okay, good. Right. Does everybody see why? Because you could just plug 2.5 in for X. Is everybody with me? Because X means number of beers. So if you know your number of beers, you could plug that in to get a prediction. Would this line give you a good prediction? What do you think? Would you trust it?
No, because it has such a low R value.
Sweet. The R value sucks. I wouldn't trust this damn thing. So no. So I'm going to be much more specific for you. I'm going to tell you how big the R value has to be before you can trust it. Right? Because and not surprisingly, it depends on how big your sample is. The bigger the sample, the smaller R could be. Does that make sense with the other stuff we've been talking about? It should. Okay.
Yes.
It's kind of like that level of evidence thing. Do not worry. This is not going to be a hypothesis test. Right? That is not the process you are looking for. Right? Sorry, it's the old Star Wars joke. Now, let's come back to this. I'm not done with the calculator, am I? What am I supposed to be able to get to show up on my screen? Right now I got this. That's not good enough. Why not? What else has to be?
Use the line of best fit.
Line of best fit. And I don't just mean draw it with a pencil before you scan it or something. Like draw on your calculator screen in pen. No, I want the calculator to do this for me. It's a freaking calculator. So look up, what's the line of best fit again? Read the whole thing for me. Anybody? What's the whole line of best fit?
Y equals negative.
Sorry, Ann. Thanks for playing along. So do you see a button? That seems to be a good place to go to tell the calculator this line of best fit.
Y equals.
Yeah, so right up here, if I go to Y equals, that is where I can put in the line of best fit. So I'm really sorry. I don't know if Ann's going to trust me now if you want to tell me negative 2.54? No. Is that right? What is it again?
Negative 2.54x plus 89.83.
Thank you. And here's your X button right there. You see that? It's like your all-purpose variable button. Is anyone staying quiet that has weird? Is everybody okay? Has everybody got to see like Y1 equals? Is anyone having anything else there?
How did you get there again?
Just hit the Y equals button right there.
And then like to make the the equal sign a block?
Oh, do you see how it isn't right now?
Yep, never mind.
And then you start typing. And here's your X button. By the way, be really careful. There's a minus button and there's a negative button. So use the negative button here, of course. Plus, what was it? 89.83? Yes? Okay. Now if you hit graph, look at that shit. I don't know about this color scheme, magenta and blue. But what's it matter? It's fun. It makes me think ice cream for some. Can't you just store? Yes, you can. Thank you. Somebody's pointing out some higher level functionality. I'll point that out once we're past the basics. Okay. Is everybody with me? Isn't that cool? No? So that is the line of best fit. And you can tell why it's freaking negative 0.34, whatever. Look how far away these points are. All right, so let me show you one shortcut somebody's trying to tell me to use. If you go to stat, remember when we went, Jeff, try again. We went to calc and we did this. Now, the reason I didn't do this at first is because when I go to, let me do that again. Go to stat, calc, number 4. How many of you don't get all this showing up? Does anyone not have all this show up? Or does everyone have this whole thing? That would be awesome. Everyone's got all this? Okay. So look down here. All right, this, you don't have to do what I'm about to do. It's sort of a shortcut. Understand? what it's going to do is the calculator is going to go into y equals and put the line for us instead of we have to go in and do it ourselves. So that's what this right here is. So if I go to store regression equation, and again, you don't have to do this. All right, where do we want to store it? Don't we want to store it into y1, right? Into that first y equals line. Are you guys with me? Y1. So let's go to, now look at it.
What did you hit to get to that screen? I'm sorry. I keep
Okay,
asking you to repeat yourself.
Stat,
Stat,
calc,
calc,
number 4.
4.
Now, let me ask you, Billy, do you have all of this show up?
Yes, sir.
Okay, so now go down to store regression equation. Do you guys agree with me that y is a variable? Would you guys agree with me that y is a variable? So look, don't you have a variables button? So if you click variables button, go to y variables and go for function, right? It's a function. Oh shit, some algebra is happening today. Function, and then finally there's y1. Okay, good Lord. So look at what this does. And again, you don't have to do what I just did if you don't want to. You can do exactly what we did earlier. If I do this though, and I hit calculate, all right, there's all the same shit, Jeff. So what's different? Well, if you go to y equals, it's put everything, holy shit, look at that. The calculator put all this in here for me. That's what that does. So I don't know if it's really a shortcut, but it's just another way. And then of course, when you graph, you get the same thing. Okay. You guys okay out there? So what I want you to do, not surprisingly, is I want you to do the other problem. Holy shit, wait a minute. Sorry guys, hold on. Where are you? There you are, okay. So do this other problem. Here. Let me see. There's more data here, so you got to be more careful about missing anything. Good Lord. Okay, there's 19 things, guys. So make sure you get them all in there. Woo-hoo. All right, so all right, cool. Try to calculate as much as you can. Try to get as far as you can, and then I'll catch up to you. Oh, cool. All right, perfect. I like it. All right, let's see what happens if I do this. I'm sorry. Is that too soon?
I'd like 2 digits left.
Huh?
Just had a couple digits left. Give me a couple seconds.
There you go.
So
Oh.
Good.
So here's this. So if I go to stat, calc 4, and if you want to, you can do, I don't know if anybody did this, vars, y vars, function, y1, okay. All right. Is this a stronger correlation than the first problem we did?
Yes.
Yes. What else is different about the correlation?
It's positive.
Good, it's positive. So it should have a positive slope. If I hit graph, I get this. I get one little point, and then this is my line that the calculator. So what did I forget to do to find all my data?
Zoom stat.
Zoom stat. Kick-ass. Anytime you put new data in, you got to tell the calculator to go find it. Look at that. That's beautiful. That's beautiful. All right. So it is stronger for sure. It's not like really, really strong because these do get kind of far away. All right, maybe. So coming back to the sheet real quick. I'm going to ask one more question that's on here. And don't worry, by the way, we're not going to take a break because I'm going to let you guys out early again. I'm really sorry if you're like, good Lord, this guy's letting us out early again. What a chump. All right, so if you like that, too bad. What was our R again? It was 0.737? Did I remember that?
I rounded it to 0.738, but yeah.
All right, I can't remember. 738. You're right. Okay, thank you. Get in there. Okay. It's this strong. Now, don't worry. I kind of relate this to tasting wine. You're like, oh, this has got a nice bouquet and hints of citrus. So, what does that mean? You're like, what adjectives do I use? So, I would say this is decently strong. So, I normally like to give you problems that it's really obviously weak or it's really obviously strong, not like somewhere in the middle. 0.738. That's not that strong, right? If you got a 73.8 on something, 74 on a test, you're like, no, that's not bad, but it's not the greatest thing, you know. Decently strong, positive, right? And the line of best fit, I sure as all hell don't remember that. I didn't even look at it.
Are we supposed to see your screen?
Yeah, you're supposed to see it. I'm not sharing, am I? That sounds about right. Hold on, everybody. There we go. So I just wrote that down. Decently strong, positive correlation, right? So I like to give you problems where it's obvious, but I also like to give you problems that are real life. I've done stuff in the past like total number of offensive yards for a football team versus how many the percentage of games they won, and it's a pretty strong correlation. You could also do defensive yards, and if you don't like football, I do problems related to politics. I do problems related whatever. So I like to get real data and have you look at the correlation between real things. I'm not going to do COVID related again. I did a COVID related one. I just sort of want to stop doing that. I think it's been analyzed enough. What was the equation again? It doesn't really matter, but 0.66 and 71 roughly.
So would you say that anything above, well, plus or minus a 0.5 would be considered a decently strong positive or decently strong negative correlation?
And the reason is it's dependent on the number of things in your sample. Like this would require a higher R than this would because this is a bigger sample. Does that make sense compared to like t-scores and how it's dependent on the sample, right? It's the same idea. So there's actually a whole other table of R values by degrees of freedom and what R value. So what I'm going to do is on a test or what quiz, whatever, I'm going to put the R has to be greater than or less than something to show correlation. If that makes sense. So for a really big sample, you could R of 0.3 might be good, but if your sample's really small, you might need R above 0.8. Does that make sense? I
Yep.
think for this one, I'm not even going to try to pretend like I'll remember. I'd have to look it up for this sample size. Would we trust a prediction made using this line?
Yes.
Yes. Would we accept it completely without question? No. Is it a better guess than just guessing the average? Shit, yes. Right? So let me ask you this. What if some student studies for 11 hours? Can you predict their grade that they're going to make?
Yes.
How?
Well, I'm looking between the 10 and the 12 hours.
Oh, no good.
No?
And that's because then you're basing it on 2 data points. You with me? I want something that's based on all the data points. Wouldn't that be better? Do I have something that I created that shows a relationship between the 2 variables that takes into account all the data points?
Yeah.
Yes, I have this bad boy. For a given X value, I can predict the Y value or vice versa, right? You understand? If I put a Y in, couldn't I solve for X? Or if I put an X in, can't I solve for Y? So for this one, where does 11 go?
An X?
Good. So if I did Y equals 0.66 times 11, and if somebody knows a shortcut for doing this, I'm going to show you in a minute, just to kind of stop any private chat that might have been coming my way. There's a shortcut to do this in the calculator, but let's do this way first. What do you guys get? And I kind of rounded quite a bit here, but you know, oh well. Anybody get that?
78.26.
Yes. So that's not the same answer you would get just by kind of like doing between those two. And again, it's because look at this, there's another 12 that got 82. So the whole thing is, I don't want to just focus on one little area. I want something that tells me, what does it seem like on the whole? Using all the data, because that's the best way to be. How can I predict this? Well, that's what the line of best fit does. Is everybody understand? You guys all right out there? Okay. And then let me show you the shortcut. And then I think we might actually do one more problem, then we'll call it a day. Let's see. Where'd it go? Here it is. So if I do this, go back to my graph. This is kind of cool. Doesn't the calculator, somebody was telling me that their graph looked different. When you hit the Y equals button, do you have all this stuff? Or did you put in there like 0.66 and 71? Whoever.
All right.
I
Sorry.
did that and got
That
it.
was me.
I did the same thing and got
Yeah.
it.
I didn't change my Y.
There you go. Okay. All right. So I skipped that step because I did the step where I made the calculator put it in there for me. But doesn't the calculator knows the equation? It's a calculator. it better be able to freaking calculate something, correct? That makes sense? So if I hit right there, see that little calc thing? Everything up here is graphically related. So that is calculate based on a graph. So if I hit second trace, I can make it calculate stuff. Look at all this weird shit. Now these two aren't weird, right? Those are kind of, that's nice. It'll calculate the minimum or the maximum of a whole graph. It'll find the intersection between two graphs. It'll do some neat calculus down here. Ooh, some calculus. Let's just do the very first one. Value. I want to know what the value is. So if here I put in, I forgot already. What was it? 60, it was 11, right? 11 hours. So if I just put 11, it'll actually find for me, there it is. Everybody with me? You might not get the exact same number because I put the entire, here, look up here. I put the entire decimal stuff up here for my equation. If you round it a little bit, it'll be different, but it should say 78 point something. You guys with me? You guys okay? So what am I gonna need to see if I give you this kind of problem on, I'm gonna need you to scan this and submit it with your assignment, with your whatever it is. Yeah. Does that make sense? Okay. You okay, Melody? What's up?
We're scanning this for the homework too?
No. For the homework, I can trust you to do this and answer questions based on that.
Can you just go back through that calculation? Because I'm not.
To do what?
I'm trying to stay up with you. For this problem, I have all the data points entered in properly.
So then all right. So you haven't gotten the line of best fit for this problem yet?
I keep getting a straight line.
Oh, all right. So you did get these, right?
Yes.
All right, so here's probably what you did. Let me go in here and clear this. Tell me exactly what you put here.
0.66 parentheses 11
Oh,
plus 71.
why would you do that? All right,
I thought it was the right thing to do.
I really want you, now listen, anyone answer me this. If I graph y equals 3, what kind of graph would that be? Does anyone know?
It would be a straight line.
What do you mean straight line? You mean completely horizontal, correct?
Correct.
So when you don't put x in, you put a number in, y equals a number flat. You don't want to be that specific here. You want to say, I want to graph every point on the line, so I better make that x to cover every possible input, not just one input, 11.
0.66x.
Plus, I think it was like 71 roughly. Right? Yeah, it looks good. Yes? Is that better? All right, so that's another thing I see a lot. People do this and they're like, I don't know why. Well, because you didn't put an X in. So of course it's not going to change every time you step over. Yeah, okay.
It looks slightly better, but I don't know what I did wrong.
Slightly better, like that?
No, I'm not getting all the points.
Okay, that's a good place to start. Were you getting the points before?
I got the last problem and then entering in this problem.
Listen in here. Every time you put new data in, you must hit zoom stat to tell the calculator to go find the statistical data, right? That's what zoom stat means.
Oh, okay, there we go.
Cool.
Thank you.
So if I put brand new data in, the calculator is still going to be looking right at this area. And all my data points might be somewhere else. So I have to tell it, go freaking find my data points, calculator. Cost enough money. All right. Okay. Maybe. I do want to show you this just because. So is everybody good now? Somebody Everybody, yeah, I think we addressed that. I was trying to catch up with chat. Let me show you if I can find this real quick. Let me think. Dadgummit. I think it's here. Yeah. Sorry, guys. Hold on. Strangers in the night, exchanging their clothes. Let me see. Where are you, Jeff? Jeff? I don't know where it is. That sucks a lot. It's not going to be there. Dadgummit. Dadgummit. It's not there no more. It's here. No. All right. Well, screw it. All right. I was going to try to show you. Dadgummit. Hold on. I can find it real quick. Bam. Here we go. All right. Let me show you this here. Oh, let's see. Here it is. Here it is. No, it isn't. Yes, it is. All right. Sort of. All right. This is not the best. Oh, no. No, I don't want to be there. Oh, sorry, guys. Sorry, guys. Hold on. So what was stats class like? It's like sitting there watching this guy talk to himself. Well, that sounds great. This might be close enough. Yeah, okay. All right, yeah, this is close enough. All right. There it is. Good Lord. God, that sucks. All right, guys, this is the best I could find right now, real quick. I have another table that I use for myself, but you guys, don't worry. This makes you feel like you're going crazy. But can you guys sort of see these numbers? 0.707. I gotta find. Hold on, you guys. Don't give up on me. Let me find. There's gotta be. Come on. I gotta find. Oh, there we go. Yes, there we go. Oh, it's a stupid site. I don't care. I don't care. I don't care. I really don't care. Let me do this. Open image in new tab. There we go. Now I can do it. Okay, now. All right, you can see this a little bit better. See how this is alpha equals 0.05, alpha equals 0.01. Does that seem familiar?
Mm-hmm.
Okay, so it actually could be. All right. So what I want you to remember, the problem we just did had 29, I think, data points. Is that right? Was it 19? What was it, Jeff? I'm sorry, guys. How many data points did it have?
19.
19. Thank you. Let me come back to that. Where'd it go? Here it is. So 19 data points. So I was right. Okay, sorry. I remembered 4, 5, 6, and it was right. So R would have to have been more than 0.456 to show evidence of correlation. We got 0.738, right? So not only did it show evidence of some correlation, it was well above 0.456, right? So what if I got 0.47? Is that evidence of correlation? What if we went and got what if we got 0.47 for the problem we just did? Is that evidence of correlation? Yes.
Yes.
Because it's greater than this. Would it have been strong or weak though?
Weak.
Weak, because it just barely crossed the threshold. What if I got 0.42?
Even weaker.
Strong.
No evidence of correlation. So I wouldn't even say weak or strong, and I would definitely never use the line of best fit. So I'm not going to give you this table. Don't worry. I just want to show you that it exists. I have a better, this is the same table I use. I just have it somewhere else. It exists. And you can see as your sample size goes down, your R value has to go up because you're less certain about what you're seeing. The requirement for evidence goes up. So you have to get a much better R value. Okay. Maybe it's, so if you really don't understand what I just said, that's fine. Because all I'm going to say on a test is R has to be greater than this to show evidence of correlation. Okay. So that answers that question earlier about was 0.5 kind of like the dividing point? Well, no, it depends on how big the sample is. All right, maybe. Okay, yeah, why not? Let's see. Today is sort of like yesterday. I'm just happy we had any class at all. So let's call it right there. It's a little early. So if anybody wants to hang out afterwards, if you have questions before starting this quiz, the quiz doesn't open until, I can just open it now with the shit if anybody wants to start it now. But if you don't want to start it now, if you want to hang out, if you got questions left over from chapter 8, please ask away.
So the lecture today will help us get started with the chapter 12 homework over the
Chapter
weekend.
12 homework, that's right.
Okay.
You should be able to do all of it. The very first section of chapter 12 is a review of lines. Good old MX plus B stuff. So we'll see how that goes. A little algebra in your life. Here we go. So let me go ahead and open the quiz up for you guys if you want to start it. Anybody need to hang out, have questions?
I have a question for homework 8.2.
Yeah. What's that?
So, number 41, I'm not sure what I did wrong. It wants you to find the 95% confidence level. And when I did that, I put the z-score as 1.96.
So I'm sorry, let me catch up to you again.
Homework 8.3, right? Has 41.
Number which one?
41.
Okay, so this. Yeah, okay, so what did you say right here for number 40?
That you should use the t-score to solve.
Totally, completely. So you were one of the, so I had a few people that did this. They said that they had to use a t-score, but then when they went to do the problem, they used the z-score. It's like, damn, you just said you had to use, so 1.96 is a z-score. It totally is.
Mm-hmm.
What's your degrees of freedom? What do you have here?
For the degrees of freedom, I have 69.
Yeah, so that's close enough to 70. So that's what I said the other day. You could go ahead and use 70 if you're like right there. Remember that? So let's
And degrees of freedom is the amount of value you have -1, correct?
yeah, it's n minus 1. Let me see. Hold on. Let me find my t-score chart. Donde? All right, let me do it this way. This is quicker, maybe, hopefully, please. Please. Thank you. All right, I'm just so happy when technology works. All right, so your mistake was you went all the way to the bottom. Z-scores live at the bottom. If you need a t-score, you better stop. And we're going to stop, of course, at 70.
Oh, okay.
So we always use standard rounding for degrees of freedom?
Definitely not. So that was this whole discussion we had. Why was I okay with degrees of freedom was 69, but it's right next to 70, so that's fine. But if you had degrees of freedom of 65, I would say go down to 60.
Okay.
But I'm going to be kind of lenient on that. If you happen to go the wrong way, it's not going to be the end of the entire universe, so don't worry. Yeah. But, you know, if I had like a degree of freedom of 111, I would not go to, if I had a degree of freedom of 150, I would use 100. Just to penalize myself, make the t-score bigger, because I'm not sure about it.
And this is from homework 8.3 because it has number 40 in it. 8.2 is 74.
It doesn't matter, as long as it makes sense. I don't care where it's.
Yeah. Okay.
So is that should explain a few of your mistakes, right?
Yeah, so just
Okay.
to go over, the degrees of freedom is 70, and then the alpha would be 0.05, and I just find where they intersect on the t-table.
Yes.
Okay, awesome.
So that's what you'll use there, and that's what you do for the other one. So when you say you're going to use a t-score, that tells you you have to stop on the t-square table, because if you go all the way to the bottom, you get a z-score. Yeah. I like it. So you weren't the only one that had that happen. Anybody else questions or?
Yeah, I have a question on section 8.3,
Yeah.
number 118.
Okay.
Letter D. I just want to know because in my Z score I put in 1.96. I think that's
Yeah.
what I did wrong because you marked it off.
All right, so I'd have to look at your specifically to see what happens. Hold on. 8. This is
Or
8.
excuse me.
What's up? Sorry.
No, I thought you said something.
Let me see. Number 118. Okay, here we go. So let's see what happened here. Oh, I didn't cross out 1.96.
Oh yeah, that's true. You cross out.
Yeah, so when you put that part in your calculator, something went wrong. The way you wrote it is a little bit different. I don't know if you square rooted 400 twice. It's like the 0.8 times 0.2 divided by 400. That whole thing is supposed to be under one square root. It seems like you might have square rooted 400 twice. Does that make sense what I'm saying?
Okay, so
So you
and
one square root with 0.8 times 0.2 divided by 400 in it.
okay.
So it's like
So-
if you divided by, if the square root of 400, if you square rooted it twice, that's why your answer was too big.
Okay, I will try. Okay, thank you.
Jeff, could I do, I mean, since these problems kind of mirror each other, could I do 106 with you? Because I was way off on 8.1 and I did it with a tutor. Well, the tutor from Grossmont, who apparently was way off as well.
So let me say my standard thing about this. Tutors are not there to make sure you get everything right.
Right. But I got everything wrong. So,
Yeah, so sometimes,
well, I had to miss one lecture to work this week for class, so that's on me.
sometimes it is the tutor's fault. I will give you that, but sometimes it isn't. So what's going on in this one?
Suppose that a committee is studying whether or not there's a
I'll
waste
read
of
it to
time.
me. I can see it. Is this the one you're talking about you had trouble with though?
No, but if I do this as a map, it'll kind of give me a guide of what's correct, and then I can correct my.
Which one were you doing?
Let's do 106. Do you mind?
No. Which problem are you talking about for real?
You X'd out most of my 8.1, especially my 98. So 98, I had X hat as 2 ounces.
X bar. Okay.
X bar. Sorry.
Okay. 2 ounces. Sure.
And then little sigma as 0.12 ounces.
That's a problem. That's a mistake. What does that symbol stand for?
Mean.
All right, no, not this one. This is good. What's this symbol stand for?
Oh, standard deviation.
Of what? Because isn't this one standard deviation also?
Oh, that's standard deviation of the sample. That's standard deviation of the population.
So that should be 0.1.
1.0.
And then the sample led to a mean of this with a standard deviation. So that standard deviation is from the sample.
0.12. Okay.
So when you went to do your formulas, you must have had a 0.12 here.
Which would make it all wrong.
Yes. So there should
Okay.
be a 0.1.
Can we just keep going on this one and then I'll hopefully understand. So BX is a small is all small bags of the same brand of candles?
No. What does that mean? Like X is a variable, is a numerical variable. So what is it that you're measuring?
The weight of small bags.
There it is. X is the weight of a small bag. You with me? Wouldn't that make X a number, numerical measurement? Okay. So X is the weight of a small bag. Keep going.
X bar is a sample of 16 bags of the same candles.
No. What does the symbol X bar represent?
The mean
So that
weight.
word better show up, right? Yeah. Go ahead.
Okay. X bar is the mean weight
Of
the sampled small
Good.
bags of candles.
the mean weight of the sample. Now fill in the sample with what the sample is. It's the mean weight of
Small bags of candles.
16 small bags. That's what the sample is, isn't it? Does that make sense? X bar is sample mean. So when you want to put it in words, X bar is the mean blank of the sample. Fill in the blank. What's the sample? So it's the mean weight of 16 small bags of candies.
And then D, T distribution because the sample size is only 16.
All right, so so much, okay. Why were T-scores invented?
For non-normal.
No, definitely not. Never said that. That never would have come out anywhere, any of me, it would have come out of. Does anyone else on this call right now know why T-scores were invented?
When you don't have sigma.
When I don't know the population standard deviation exactly. You with me, Billy? And again, remember these two formulas here? What is T sitting next to? S.
For when you don't know the population standard deviation.
And do we know the population standard deviation?
Yes.
Yes. So we're going to use Z-scores. Right? Now, there's one other thing you have to say.
Z-scores because we know the population standard deviation.
And? Is this a normal distribution?
And this is a normal distribution.
Well, no, I asked you. Is it a normal distribution?
It tells us.
Good. Yes. Okay, thank you. I wanted to make sure you were seeing that. Okay. So that is concerning to me if the tutor made this mistake. That would be very concerning to me.
Yes, I'm not going to use the same tutor again.
Well, you also should inform. Well, to be honest, I just took over like 2 days ago as the coordinator of the Math Study Center. So if you remember the name of this person, I can try to do something.
I actually don't. He's it's a he with a slight lisp.
Lisp, okay. And wear glasses or no?
Didn't show a picture.
Didn't show a picture. Okay, all right. Well, okay. I can figure it out. I can look you up when you were there and who was on duty.
I've been there pretty much every day before class, so I'm worried about the information I got from this guy. Anyway, the mean weight was 2 ounces, a standard deviation of 12 ounces. Z-scores because we know the population standard deviation. And that it is a normal.
I'm just going to pop in here for D. When it asks which distribution should you use for this problem, it's asking for a Z-score or a T-score. That's it.
Yes.
So how do you indicate that?
How do you mean? So you would say Z, comma, here's why, or T, comma, here's
Okay.
I can't say because.
why. Yeah.
I'm just really trying to do better in your class, man.
I don't care about word choice. I mean,
Okay.
that's an synonym.
Okay, so then constructing a confidence interval would be confidence interval equals mean plus or minus z-score, standard deviation of the population over root n.
Yes, and you know everything except Z, right?
Well, yeah, now I'm using a different chart, so that changes all my answers.
Okay. Yeah. So now you want to look up the Z score for 90%, right?
Yeah.
What's alpha? Alpha is always the area that's outside. So if there's 90% inside, what area is outside?
Each tail is 0.05.
So it's 10 total, right?
Yeah.
So if you look on your T-score chart, 0.10, two tail, you go all the way to the bottom, you'll find your Z-score.
Okay. Thank you for the help on this.
Yeah.
So confidence interval equals 2 plus or minus, and let me go bring up my T-score chart. Okay.
Wait, I thought we were using the z-score chart for this problem.
But if you go all the way to the bottom, it is a z-score, right?
Okay, because
It doesn't
I
matter.
was confused as why there was a tail, because I know there's no tails mentioned on the z-score chart.
Yeah, because the Z-score chart has tails built into it, right?
So this is two tails, area and two tails is
0.10.
0.10. So we
If you go all
go
the way to the bottom, what do you get?
1.645.
There you go. Cool. So now you throw this in the calculator, figure out what that is, and then add it to 2 and subtract it from 2, and you got your interval.
Okay, if we could keep going on the same problem, because
So
I
F, the reason I say no is because the only difference to what we just did with all this is it's 98% confidence. So what would alpha be then?
alpha would be 0.2.
0.02.
0.02.
So then you would look at 0.02, two tails, go down the bottom. So instead of 1.645, which is what you use for part E, you're going to put something different in for part F because it wants to be more confident.
Yes, so it's going to be 1.2.
0.02 in two tails.
2.326. Let me make sure I'm
So
reading.
I want you to understand, if you get part E, you must get part F because the only thing that changes is you're going to put 2.326 here instead of 1.645 for part F. Because I want to be more confident in part F. Does that make sense?
Yes. And then the air bound, how do you want that said? I just put
Let's listen.
Z.
I don't need it said any specific way. It's just going to be whatever it is here, right? That's why I always say calculate this first, because then you know what the error is, right? No? Hello?
So do you do plus and you do the minus and then you add them together and that's your air bound?
No, 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 no. This is your error.
I'm not.
What?
I'm not seeing. Okay, that is my error. Okay.
So when you do 1.645 times 0.1 divided by square root of 16, whatever the numbers you get, that's your error. Why does that make sense? Because it's 2 give or take this. So it's as much as I think I'm off by. I think it's 2, but it could be off by this much. That's why that's called the error. It's how much I think I'm off by. Give or take. Does that make sense? The plus or minus, give or take this much?
Because if 2 was like your middle point, and then the second part is just like a z-score times the new version of your standard deviation. So just it's looking at your middle point plus or minus however far would catch the
Yes.
information that you're
So
looking
certainly
for.
I'm like, you know, somebody's like, how many people are in that room? And I'm like, 40, give or take 5. You know, so I think I'm off by
5 somewhere, yeah.
off by 5. That's my error that I kind of built in. Yeah. Everything we do actually does have a bit of a physical analogy that makes it make more sense. So it's not everything has to be memorized. Oh my God. With all the math I know, if I had to memorize all of it, I would be a gibbering idiot. There'd be no room in my brain to remember how to breathe if I had to memorize everything that I'm able to do. Right? And that I think
Okay.
makes math hard for a lot of people is they think, man, Jeff, how do you memorize all this? I'm like, I don't.
Okay. I'm gonna keep going through this homework then because, yeah, it's my fault for being a day behind this week. I just had to take work because I'm poor.
And like I said, I mean, I'll try to find out who it was, but they're supposed to still have a way to evaluate tutors for students. And so if they're not telling people how to do that, that's not good because we need to keep our tutoring program useful and helpful. So yeah.
Okay. Well, definitely. Yeah. But I'm going to go back and watch your lectures and just basically re-educate myself on chapter 8. Which lecture should I start with? Is it the one from 4 days ago or from 6 days ago?
I just did this yesterday. You go to July 6th and it starts at 8.1. And you watch it all the way until July 12th. And it's only 3 lectures because we had the long weekend.
Okay.
I have descriptions on all my videos, so I'm hoping that would help.
All right, I'm gonna just go through and do that right now, and hopefully I will know, and I'll stop wasting your time.
Oh, please. You're not wasting my time. The people that are not asking me questions are wasting my time.
I can keep asking questions. On 102, because I'm gonna fill in F on my own time, now that you've given me the proper way to look at this. 102, I got the point estimate is 69,821. It's simply me.
That's in the middle. I like it.
Okay, the air bound is 101.
Yeah, because that's how far away the middle is from either side. Yes.
Okay, so then I got the standard deviation equals confidence interval minus
Wait,
X
are we
bar.
still at number 102?
Yeah.
No, you're done with number 102. All it wanted was the mean and the air bound. Stop doing stuff.
Okay, and then 103,
Good.
you must measure at least 30 to make student's height to have a 93% confidence. Our
Are you saying 30?
previous
No. Sample size has to be at least 30 for it to be normal. That's not what this is asking. Right? So what formulas did we get from this chapter? So we got this formula. Right? We got this formula. These two formulas kick ass because this tells you when to use Z and this tells you when to use T, right? Use Z when you know sigma, use T when you only know S. Does that make, it's kind of awesome. It's a note that I have to let you have. And then we have this formula for percentages. Is this cool so far?
Yeah, I'm just scrolling to a page in my notes to put this in so that it's like obvious and comprehensive.
Now,
Okay.
we also got this formula from that worksheet we did. And this formula, so these three, they have that look of a confidence interval, plus or minus. It's something going up and down. So those three are what you look towards when I say create the confidence interval. Then you just have to pick which one. You know it's one of these three because they're the ones that have the plus or minus in them. With me?
Yes.
This question is how many, what letter relates to how many? What variable will relate to how big your sample is? How many?
P hat.
No, that's the percentage.
Oh, I'm sorry.
The sample size. What letter?
Oh, so it would be X bar plus minus T S.
Stop. Is this problem asking me to create a confidence interval?
No, it's the
So
one
it's
that you circled.
Not going to be one of those. It's asking me how many. How do I know it's this formula? Because sample size is n, right? The number of things in your sample is the letter n, right? Right?
Right.
All right, so I know I need a formula that's solved for n. So don't they tell me the average height of young adult males has a normal with a standard of 2.5? That's my standard deviation. Right? They tell me 93% confidence. I could figure out the z-score. Right? Because what do I need for my formula? I need z, I need sigma, and I also need the error. Now this one's hidden a little bit. How far off do they want to be in 103? How close do they want to get?
93% confidence.
That's how confident they want to be. How close do they want to get to the height? So how close to the real height do they want to be able to get?
Within 7%.
No. You just said a magic word though. Stop looking at 93% confidence. That's how confident they want to be. I want to know how close they want to get. And use the word within, which makes sense. You want to be within something. It tells you how far off you want to be, which is the error. They want to be within how much?
Within 1 inch.
Yeah, so the error is 1. Yeah, so now you got everything you need. Look up the z-score for 93% confidence. You got the standard deviation 2.5. You could put that in there. And you got the error is 1. You could throw that in there. So the more important thing is, how did I know to use this formula? Because it said how many. This is how many do I need? How large of a sample do I need? How many people do I need to talk to? How many? That's n. So then I know I want to find a formula that's solved for n.
Okay. This is great. Thank you.
Yeah.
You're saving my behind on this test.
I'm just gonna pop in again real quick for 102. I guess my question was, I wasn't sure what you meant by find the point estimate.
Oh yeah, I keep forgetting.
Understanding the question. Half of the time, the homework, I know how to do it, but I don't understand what the question's asking to do it.
Listen, if we talk to 87 people and we found that 11 of them like ska music, right? What's our estimate? What's our estimate for what percentage of all people like ska music? Could we estimate?
Right,
What?
we could just take like
11
11
divided by
divided into 87, which is 0.13%.
Yeah, so 13%.
13%, yeah.
So that would be our estimate. But so what does that mean then? P hat, X bar, another name for those is point estimate. It's our best guess for what the answer is. Right? So how do I get the best estimate for the population mean age of gross month? I take a sample.
Mm-hmm.
I get is my best guess, my point estimate.
So in this case, are they, let's see, they're asking for X bar.
Yes.
So then what's the P hat for?
There's no, this is not a percentage problem, so it doesn't.
Oh, okay, it was just as an example of what a point
If
estimate
it's a percentage problem, then P hat is the point estimate. If it's a mean problem, then X bar is the point estimate. Yeah. So X bar tries to estimate mu, P hat tries to estimate P.
Okay.
There you go. Okay. I used to listen to ska all the time. It's kind of funny.
Dude, playing ska is really, really fun. Playing bass in a ska band was like one of my best jobs ever.
I'll have to take your word for it. I was never good with musical instruments. One of my weakest points in life. I got a guitar, tried to teach myself, and I got one chord, I think, and then I was like, I can't.
So 102 kind of goes backwards in that it gives you
Yes.
the
The end. It gives you the confidence. Yeah. But I mean, it's pretty straightforward. I mean, like I said, if I had a confidence interval 5 to 11, the mean must have been right in the middle.
Right.
It must have been 8. And then,
assuming that it's not normal.
say again?
This is because it's not normal?
Why? Why do you say that?
Because I was looking, let's see. Oh, wait, never mind. I don't know. It just
So it
seems
has to be, well, to be really honest, it doesn't have to be normal because we know we can do t-scores, right?
right.
Well, and that's not because it's not normal. So it does have to be normal, but I mean, I'm thinking about stats 2 now. There's other things you could do if it's not normal. But for everything we know, it had to be normal. So we're just assuming since they created it, it was normal.
So what was the 5 and 11 with the 8 in between?
Well, I'm just giving an example. Instead of these gross numbers, right? An interval from 5 to 11 isn't 8 right in the middle?
Right.
That would have been the mean then. And then what did I add and subtract to 8 to get 11 and 5? 3. So it was 8 and the error was 3.
Okay.
What z-score would I use for 103? I'm kind of confused right now.
You draw the confidence interval for me. Draw it. Where's the 93%? What does a confidence interval look like?
It's the area in between the two tails.
Good. So it's 0.93 in here.
So outside is 0.25 on each side.
No, definitely not.
Point 35.
Oh, 35.
35.
Not 35%, but 3.5%, right?
Mm-hmm.
So if you look up 0.035 in the z-score chart, you get the negative part, and the other part is the same number, right? Because it's symmetric. So that's the old-fashioned way before we had any shortcut. I don't know if you remember doing that. We used to have to do that for 95%, 99%. Now we can just look at the t-score chart and get it. But 93% is not represented on there. Too bad.
102, they give you all this information, but all you really need to do is find the midpoint between 69,720 and 69,22.
Yes.
Oh, so the z-score is 36.32 positive and negative 36.32.
Where did 36?
0.3632.
No.
I looked up a z-score of 0.35.
Okay, so 2 things wrong with that.
It's not 0.035.
It is 0.035, right?
Yeah, that's not what I looked up.
And more importantly, this is not a z-score. Isn't this an area? You have to look it up in the middle of the z-score chart. That's where the areas are. I'm trying to find a z-score. So what's the closest you can get to 0.035, and then you look out to see what the z-score is, right?
Okay. 0.0351 is negative 1.81.
Okay, good. So now you know it's 1.81 is your z-score. So z is 1.81, e is 0.1, sigma is 2.5. That's all you need to throw into this formula, and you can calculate what n is.
Okay.
All right. I think, yes. I'm gonna have to call it there. The meeting at 4:30, I want to get ready for.
Thank you,
Standard deviation of 2.5 squared. And the point of measure of error. What is E? I'm sorry, on 103, and then I'll shut up.
Yes. Sorry?
E for 103.
Well, we figured that out already, didn't we?
E
They want it
equals
to
1.
be, yeah, within 1. So that's the error. That's how far off they want to be. Yeah.
Okay. Thank you very, very much. That was so much clarity in like 5 minutes.
Yeah.
All right.
Yesenia, are you out there? Are you okay?
Yeah, I was just gonna ask some questions about the midterm, but I can just ask like tomorrow. Like I don't mind.
What you got? I got a couple minutes here. What you got?
Well, can I just check my answers real quick for number?
Oh, there are office hours tomorrow?
Not tomorrow, no. Today's Thursday, so I don't know, Yesenia, if you said tomorrow.
Oh, there's no class tomorrow?
Yeah.
Oh, tomorrow's Friday.
Yeah.
Oh, shoot.
It doesn't feel like that.
Okay.
For some reason, it feels like Wednesday, but it's not.
I thought it was Wednesday. Well, just real quick for number 4D, for the mean and standard deviation, for the mean I got 7.289, and the standard deviation I got 1.1711.
Yep.
Okay. And then for E is the 80%?
No.
Oh.
So what did you do? Let's see. What did you do in part E?
So I put the mean in the middle, which is 8, right?
No.
And then
No, it's not 8, right? You told me what the mean was just a second ago.
7.289.
There you go.
Okay. And then I would just add and subtract the standard deviation.
Yes. And then the thing is, for example, let's say that 7 is in there, right?
Uh-huh.
You'd have to look up at 7 and see what percentage are 7s. And that's how much you caught so far. And if you caught the 8s, you would have to add their percentage, because that would be the total percentage you caught. You with me?
Yeah.
Because there's not just one 7, there's a percentage of 7s.
Mm-hmm. Yeah. Okay. And then for the tutoring, like I'm looking at the on Canvas, it says math drop-in tutoring, and I just click and like, how does it work?
So where'd you go? There's a couple different ways. So there's tutoring.
I did the Grossmont tutoring.
Well, yeah.
I went on tutoring, and then it just it says math drop-in tutoring here. Yeah, that one.
That will put you into a Zoom room. So I don't know if you could do it right now since you're in Zoom already.
Mm-hmm.
When you go there, there will be a person that you tell them, I need stats help, and then they put you in a breakout room for stats help.
Oh.
Okay. And that'll be open tomorrow, correct?
Yeah, their hours, I put their hours. See, I have a whole tutoring module here too. Here's tutoring. Yeah, so there's the link again right here for drop-in tutoring. Oh shit, no tutoring on Fridays, it looks like.
Oh no.
That's all, get this, our budget 2 years ago, or compared to 2 years ago, our budget has been cut in half.
Jesus.
Because the college, the priorities of the college are whack. So that's why we couldn't, look, we could only be here 11 to 3, and we can only be here Monday through Thursday. It's really bullshit, but that's all we got.
Can I like pay you through Venmo or something?
You
For tutoring?
can ask tutors if any of them are working outside of Grossmont. Sure. You could I would cost a lot of money, and this is why, since I'm your teacher, I just tell you to email me times that you can meet, and then I'll see if I can. Tomorrow is not going to work for me at all because I have a doctor's appointment, and I'm not going to feel like doing anything.
I'm gonna head out, Professor. Thank you for your time.
And tonight, no.
Okay. I'll just watch the lectures and learn from them and then do my best.
Cool.
All right. Thank you very much for your time, sir.
See you, Billy.
All right. Always appreciate it, man.
Oh, yeah.